Hello again. So now we're moving on to section 2, which is all about functions. So again, we have some more vocabulary here. We have to know, what does it mean to be a function? So good note taking is to label what we're talking about. This is section 2, which is about functions. And let's put the definition. A function is a relationship where each input only gives one, and we're going to capitalize and underline that, output, because that's the key word, okay? Each input can only have one output, okay? Now, these have very important meanings in real life, so I'm going to give you some examples. But before we do that, I'm going to give you some visuals. These are called arrow diagrams. If I take some inputs and map them to some outputs, we'll be able to see when we have a function and when we don't. So let's say we have these inputs, doesn't matter what they are, I'm just going to do dots, and then I have these outputs. If every input maps to one dot, this is a very beautiful function. As a matter of fact, this is called one-to-one because everybody has a partner. So this is a beautiful example of a function. It meets the description that we just wrote above. Let's do another one. Here we have our input. Here we have our output. Let's say we have these input values and these output values. And let's say that we have arrows coming out of each input. But these two arrows are going to the same output. Well, let's see if that's a problem. Every input can have one output. This input has one output. This input has one output. This input happens to have the same output, but it still only has one. So as long as there's only one arrow coming out of the input, it is, in fact, a function, because this input still only has one output. Okay, it doesn't say anything about not being able to share. They are allowed to share. Well, then what does it mean to not be a function? So let's look at our last example. We have our input. We have our output. Let's say we have these two inputs. And this one goes to that output. This one goes to this output. And then there's another arrow going to another output. Now we have a problem because this input has two arrows coming out of it. It is going to two different results. We can't have two different results because then it is not a function. So this is our example of not being a function. Okay? So now let me go through and give you an example of each of these in real life. Okay? Hopefully you've all used a vending machine before, or you've seen how a vending machine works. Vending machine, besides putting the money in, because we know they all take money, you have to press a code of the candy you want, and then that candy is supposed to come out. Okay, that's how it works. So picture yourself going up to a vending machine, and you've got such a selection. Everything is different. So all different codes giving you all different candies. That would be like this example. Each code giving you a separate candy. Beautiful, okay? That's a beautiful vending machine. It is functioning. It is working, okay? Did you ever go up to a vending machine and see M&Ms in two different spots? Sure, and that machine is not broken. It is still functioning. All that means is that two different codes, can both give you M&Ms. That's not a problem. Two different codes will result in M&Ms. Okay, that's fine. That is still functioning. It is still working. Now, imagine yourself going up to a vending machine and you really, really want M&Ms, but you see the same code underneath M&Ms and pretzels. Do you know which one is going to come out when you select that code? No, and that's a big problem because if I put in that input and I don't know what the result is going to be, I have a big problem, and that machine is not functioning, okay? So it is not a function. So that's what we're talking about here. This has real life implications because when you tell a computer to do something or you tell any kind of machine to do something, you want to know exactly what it's going to do. So that input has to result in only one thing, one outcome for it to be functioning, okay? For it to be a function. So this is what we're talking about for functions, okay? Now let's take it back into math, okay? You need to be able to recognize functions in a variety of different ways. So the first way is with a set of ordered pairs. Let's say you had the point 1, 2, 4, 5, 3, 9, 2, 6, 4, 8, and 7, 9. Okay, so this is just a set of ordered pairs, okay? Meaning that this input goes to that output, this input goes to that output, just like the previous videos described, okay? Inputs and outputs. And our question is this a function? And then why or why not? Well, let's think about this. Think about it as the arrow diagrams. You can even say them out loud. Pressing 1 gives me 2. So input 1 gives me 2. Input 4 gives me 5. Input 3 gives me 9. Input 2 gives me 6. So far, I haven't had a problem. Input 4 gives me 8. Well, wait a minute. I said input 4 gives me 5. Now I'm saying input 4 gives me 8. That's not allowed, okay? And then I have input 7 gives me 9. I also notice that the 9 is being repeated. 3 gives me 9, but then 7 also gives me 9. Remember, that's not a problem because you can get the same results multiple ways, okay? We don't have a problem with that. But if the same input gives us 2 different outputs, that is a problem. So I'm going to circle this problem area. 4 gives me 5, and then 4 gives me 8. That's not possible for a function. So the answer is no, this isn't a function because the input 4 gives 2 different outputs, 5 and 8, if you want to be specific. Now, if it just repeated itself, 4 goes to 5 and then 4 goes to 5, that's not a problem because you're just repeating yourself, okay? It's a problem because it's going to 2 different outputs. All right, so far we know what a function is, okay? That's what we're looking at for a function. Now we're going to talk about what a function looks like when you write it in mathematical notation. So we're going to talk about function notation. You're going to know if something is a function because they're going to label it as f of x, okay? Or f of something or something with parentheses. It's going to look like this, okay? Let's define what we have here. We know that y is typically output. We know that x is typically input, and it's kind of visible. You're plugging something in, okay? So that makes sense. But now we've got this weird thing here. We've got this f here. Don't let that f throw you, okay? It actually doesn't mean anything in terms of doing anything in the problem. It is simply the name of the function. It's like something standing there and waving a little flag saying, hey, guess what? I'm a function. That's all. So it's saying if I do something to x, okay, I will get an output. So the output is a function of x. That's all this means. So you can read this as y equals f of x. That's the shorthand way to say that. Or you can read it as y is a function of x. Keeping in mind that even though it's being read this way, the x is still the thing that has to happen first. Okay, remember our first video. This is input. So the output is a function of the input. Let's actually write that as well. Output is a function of input. So even you can say it this way, but remember that your ordered pairs are going to actually be input comma output, okay? Because the input has to happen first. If you think that this is going to be confusing for you because you've got another letter thrown in, notice that there's an equal sign in here. That means that y and f of x are interchangeable. So if you really can't get the hang of f of x, if you would prefer to get rid of f of x, you are free to cross out f of x and replace it with y. But realize that that's not a substitute for still understanding the function notation. But you are perfectly allowed to do that in your own work. So we can write that here as well. Anytime you see f of x, you could, you don't have to, but you could cross it out and replace with y equals. So if that's going to make more sense to you, okay, definitely do that, because I don't want you hung up on the idea of f of x. Keep in mind, f is not a variable. You cannot solve for f. You will never be getting just f by itself. This is not multiplication, okay? It's read as f of x, okay? It's just the name of a function. Again, I'm highlighting all these things because those are the most common mistakes that I see, okay? So make sure that you realize that f of x is just another way to designate an output, okay? And it's just like waving a flag saying this is a function. So now let's do an example with function notation. Let's say that we have f of x equals 2x minus 3. Our first question is find f of 1. Okay, so find f parentheses 1. This is where your knowledge of function notation comes in. Okay, you're still going to be responsible for understanding what they're asking you. So where is this 1 in place of? This is in place of x. Okay, so this 1, we'll just put a little arrow here. This 1 is our input. So if you remember in the previous video, I said the most important question you can ask is, do I have input? Do I have output? Okay, or what is my input? What is my output? This is an input here. My input here is 1. So what it's telling me to do in not so many words is I want to replace x with 1 and calculate. That's what I want to do. So in the function, everywhere I see x, I'm going to put 1. So f of 1 is 2 parentheses 1 minus 3. Everywhere I see x, I'm substituting 1. And remember, plug in with parentheses. So now I do some calculations. 2 times 1 is 2, and 2 minus 3 is negative 1. Now, shortcut, let's take out all the work I just did. F of 1 results in negative 1. So what I just did was I found the ordered pair 1 comma negative 1, because my input was 1 and my output turned out to be negative 1. So function notation is actually doing you a little bit of a favor because it's reminding you what your input was. It might look confusing, but it's actually supposed to be there to help you. Now let's look at a different question that could be asked from the same function. Okay, I'm not changing the function. What if they asked, find x when f of x equals 3? You still have to ask yourself, do I have input or do I have output? Look at where the 3 is. The 3 is alone. It's not inside the function. It is by itself. So this, you have to understand, is an output because it's a result. It's by itself. It's not being plugged into the function. So once I recognize that, I can also do the little trick I mentioned before. F of x is just a fancy way to say y equals, okay? That's how I know that that's output. So that means that I'm going to take f of x, which I'll write down the function again, just so we have it all in one spot. Remember that our original function was f of x equals 2x minus 3. F of x, or y, if you want to cross it out, is 3. So this is going to be 3 equals 2x minus 3. So I'm going to substitute 3 in place of f of x, okay? Or y, if you like that substitution. Here's where you have to remember a little bit of two-step algebra. I need to get x by itself. So we go from the furthest thing connected to the x, which is the minus 3. The opposite of minus is plus. So we're going to add 3 to both sides. That leaves me 6 equals 2x. Then I need to get x by itself, so I'm going to divide by 2, and that leaves me with 3 equals x. So I just found out that the ordered pair 3, 3 will also be on this graph because I found that f of 3 will give me 3. Now, there's going to be a worksheet that's going to be available on Blackboard, okay? And I know this one is already plugged in, but I would like you to do it on your own, okay? And it asks you to go through this idea of a function and answer the questions. So I would like you to do that on your own. I hope this video made sense. Please always reach out if you have any questions, and I will see you in the next video.